Well, welcome everyone. This is the fourth economic session at ICCS, and my name is Sanith Wijesinghe. I'll be the chair for this session. Just a couple of admin stuff before we get started. You've heard this hundreds of times already. Please stay on mute and make sure your video is off unless you are presenting or have a question. We have 4 presenters today, and so going to try it for 15-minute presentation followed by 5 minutes for Q&A, and that still gives us a little bit of time at the end as well. So let's see if we might have more of a group discussion depending on where we end up. But otherwise, we have all of our presenters here, and first up is Harold Hastings, and his talk is on empirical scaling and dynamical regimes for GDP, challenges and opportunities. So Harold, if you would like to take it away.
Thanks, Sanith, and thanks for everyone for being here, and to the organizers of ICCS. It's been a wonderful meeting so far. I expected it, having been at the meeting 2 years ago. May I share my screen?
Please do.
Okay, so I'm going to talk about some observations about scaling in just rank order data on GDP. And it turns out that when we look at the scaling behavior of the GDP and the per capita GDP for approximately 200 countries for which I have data, that it shows some interesting patterns which lead to some challenges and some opportunities, or perhaps trying to identify how we might better alleviate poverty in the world. This is joint work with Tai Young-Taft, a colleague at Simon's Rock, and I think we'll both be pleased to take questions. So here's just some data. It's US dollars, it's purchasing power parity. I'm looking at 1980 and 2016. This is what I'm going to be talking about. We can look at years in between, but the patterns are quite similar. What we have above is the data for countries, and below the per capita data for countries, and by rank. So 1 is the highest ranked and so on down to about 200. And in all cases, what you can see looks like a power law at the high end. For the GDP, it's about a 1 over rank power law, and otherwise it's a slower decrease. And then you have an area where it falls off exponentially, and then you have an area where it looks like it falls off as e to the minus x squared, e to the minus rank squared. The breakpoints were done by hand by just trying to maximize the coefficients of correlation. The data is not very sensitive to the breakpoints. They seem to be really, really present in the data. And whereas a log normal distribution will have some of these characteristics, the Kolmogorov-Smirnov test says it's very unlikely that it's just a simple log normal distribution. So there are 3 distinct scaling regions that you saw on the previous slide. And it seems to me that similar dynamics would generate similar scaling, so this likely represents differences in dynamics. There are a bunch of references at the end, but so I don't have the years right with me. Garla-Shelley had earlier also shown the same thing for the GDP of the largest economies, follows a power law by rank, and then we've added some stuff on the multiple scaling regions and on the per capita GDP. The patterns may well be universal. We think they likely are. They certainly have persisted through time. There are some targets for growth of potentially less developed economies, namely if they represent differences in dynamics, we could look at typical economies within each region and try to have some idea of what may characterize them. And in particular, economies which have changed regions. So for example, South Korea, Taiwan, China, Equatorial Guinea have moved up to the power law, the highest scaling region. And Libya kind of, well, it was a victim of a war. Libya fell down from some level to the lowest, and so we could try to explain and exploit these. Elliot Montrol and Mike Schlesinger had sort of looked at saying that the very wealthy have some amplification processes, investments, other things not available to most. And of interest to me is that Reed and Hughes showed how if you have exponential growth and random observations in time, then you can get power law processes. So here's the data again that we're looking at. Let's see, I think you can see a cursor. And so these are the economies with the high-end GDP. And then we have exponential fall off and e to the minus x squared. And if we could bend the curve up a little bit, we could achieve a huge difference in the per capita income in the economies. This is the scale in US dollars, roughly 200,000 at the top. It's a log scale, and down to 200 at the bottom. The data has been remarkably persistent through time. I'm showing here a graph of the 2016 per capita GDP vertically against the 1980 per capita GDP horizontally, and the colors correspond to the regions in the preceding graph. And I've just identified a few economies that have moved up or down notably between regions. They correspond to the 1980 regions. And so those that moved up, Equatorial Guinea was oil, shared it. The wealth was shared, sort of unusual among the oil countries. And this group of countries all industrialized. And we'll have a little more to say about that a little later. There are some correlates of per capita GDP, and I want to say a number of things. That first of all, these are not all independent. Secondly, some are changeable and some are not, like the location of a country is not changeable. And cause and effect is somewhat more complicated too. If you look at, for example, energy use versus per capita GDP. So let's see, figure A, the top left, the darker colors are a higher per capita GDP. The figure at the top right is a corruption index, and moving up here is less corruption. It's hard to define, but I used one of the indices that are around, a group that calls itself something like transparency.com. If I'm looking at logistics, a measure of logistic performance for questions of connectivity. I could look, if I wanted, for example, electricity availability. I could look at internet availability, a variety of things. But again, the lighter colors here are better performance, and energy use, the dark red, is the highest. And we see a correlation. North America, Europe, Australia, New Zealand tend to rank high in per capita GDP, low in corruption, high in logistics. China's high in logistics, but more recently developing as an economy, and high in energy use. So there are a number of correlates, but one comment on this, that if Africa were to develop quite a bit, in addition to expected population growth in Africa, one expects an increasing energy use, and thus, despite the need to reduce carbon emissions for global warming, that will likely increase. But here are just a number of correlates. One could look at improving logistics. Significant fraction of the food in Africa rots en route from farm to market. One can look at questions of a more transparent government, and these are just a few of the correlates of per capita GDP. Inequality and economic growth, there's a complex relationship, which I and I have tried to understand. If you have a low per capita GDP, increasing inequality is associated with greater growth, probably because you need some investment funds to get going, to kick it off. And if they have a very low, this is just a direct quote from World Bank data, if you have very low, as referenced in reference 29, if you have very low per capita income or per capita GDP, if it's distributed evenly, there's just not much left over for investment. On the other hand, perhaps this identifies targets for investment, which would then be beneficial. On the other hand, at the top end, increasing inequality is associated with slower growth. And incidentally, a student of ours, Thomas Wang, spoke about that in a previous economic session and some models that agreed with this observation in the data. We could also look at education. And here I'm using UNHDI, Human Development Index components. And it's sort of, no matter how you look at it, there's a correlation between the per capita, here gross national income they used, coded in colors, life expectancy, and years of education. Of course, it's hard to say what comes first. An educated populace is good for economic growth. On the other hand, you need some economic ability to educate the populace. And so again, this may be a case of targeted investment or creating educational opportunities. And in fact, you get a very, very high correlation. For example, if I look at the income and as an exponential function in years of education, or log income as a function of years of education, R squared is 0.7, which is pretty darn good for a social science economics model, and it's highly significant. Again, I've said a bit about cause and effect, but perhaps an area for intervention. So just a brief summary, and we'll go on to questions. Number one, there are 3 distinct scaling regions. If you simply look at the data in both GDP and per capita GDP, it represents a power law at the high end, an exponential decrease in the middle, and a more rapidly decaying low end tail. You have a much steeper slope if I look at the overall GDP, because there's a correlation with size of country, but it's rather complex. I mean, for example, Denmark is a small country, but well-connected part of the EU, so that the relationship is very complex despite a small population and versus, say, a country with a much larger population. But here's a picture of the scaling regions. And again, if one could just bend the curve upwards, one might achieve a 10 to almost 100-fold increase in per capita income, even if you simply reach the tail of the power law. Where's the tail? Well, right, yeah, here's the cursor. So we then have sort of identified a potential strategy for economic development. We can try to identify important features of the wealthier economies, as well as those that have made this transition from 1980 to 2016, that have achieved economic development. And then think of targeting some of this as a development goal. And then given the highly nonlinear nature of economics, we plan to use George Sugihara and Ye's empirical data modeling to explore causality, where we can try to, where George Sugihara and his group out at UC San Diego have developed methodologies for essentially studying equation-free models that might let you get some other ideas about causality. And with that, I want to thank you very much. There's a long list of references. I'd be pleased to share the slides with anyone, and I'll take questions.
Thanks so much, Harold. And I see your co-author Tai is here too. So questions for them.
Thank you for your talk. I have a question about like what are the countries that lie at this breakpoint, and whether or not the breakpoint between power law and exponential, and whether or not they're the same countries that lie at the breakpoint for per capita versus overall GDP.
It's roughly the same countries. There are some differences. So I mean, one of the obvious differences is for example, while China is now above that breakpoint, but take China and India with enormous populations contributing to their GDP, and certainly both were economically had very low per capita GDPs in 1980. China's had a rather remarkable growth. And at the other extreme, you could take some very small countries with very high per capita GDPs, I don't know, Luxembourg, Denmark, small, well-connected countries that are highly industrialized or otherwise have become centers. Ireland, both a financial center and due to, in my unhumble opinion, a strategy that has deprived the world of deserved tax income. But they'll of course flop across. I have looked at getting a correlation, for example, between area and per capita GDP, which gives you a very weak correlation that would explain some of the similarities.
What sort of countries lie at the breakpoint? Like, what's like a collection? What's like a typical countries that lie at this breakpoint?
Yeah. Let's see. I could get the data. I have a large spreadsheet with it. Let me see if I can actually get that. Yeah. Holy cow. Let's see. Data. Oh, okay. Yeah. No, it's going to be, well, let me just take a rough guess looking at the data. Near the break point, for example, at the high end is Brazil is just above the break point in per capita income.
I see. Thanks.
And the way in accessing the thing that led to the graphs, I deleted the countries before some of the sorting, so it's a little harder to pick it out. But frequently there are countries either at a development change, or they may lie near the break point for something that really doesn't indicate quality of life. And I don't know where Denmark lies in the overall GDP, but I think its population is just a few million, and so that would pull its overall GDP down despite a fairly high per capita GDP. Same for Norway and so on.
All right, thank you.
We have a question on the chat from Oliver. How about some environmental correlations as deforestation or land use change?
Tai, why don't you take that? I'll just say we need to look at that. Certainly there are these correlations, and it may be somewhat causal in both directions. It's an important question, Oliver, and I think we need to look at it. Thank you very much. I mean, if you want, we should look at it together. Much as this observation that if you look at energy use, another environmental factor, converge and contract was one of the things IPCC used, that if all the countries converge to the energy per capita carbon emissions or per capita energy both of these, energy efficiency of the most efficient European economies, and then that contracted sharply. This becomes a kind of, in some sense, equitable way to sharply reduce carbon footprint and carbon emissions. But clearly, one of the economic correlations is that very little energy is used in sub-Saharan Africa per capita, not because they're particularly efficient in producing GDP. It's because the current level of economic development is relatively low, and it will rise. So I think this really is an important thing to look at in terms of the simultaneous achievement of economic development and reducing deforestation. In the chat of one of the previous economic sessions, there is the question that we don't do very well at including externalities and including national priorities in terms of really understanding per capita GDP and then, understanding development.
Go ahead, Tai.
Yeah, just following up. Thanks for the questions. We did, as Harold suggested, we did look at energy usage and carbon dioxide emissions. And there is a, more or less positive correlation between those things and the different levels of development, but there's no clear sort of nonlinear aspect to that data as there is in the GDP data. So there, but there is a correlation. But thank you for the deforestation suggestion. I think that's quite relevant, particularly over time, because that relates to fertility of the land, and perhaps also fuel. Like I'm thinking of Haiti, for example. I wonder what Oliver, you mean by land use change? I mean, what is that? Does that pertain to like an agrarian, to like a urbanized setting, or what do you mean by that? I guess, and then with respect, and then I'll just also say the same thing Harold did in terms of the crossover. So there's also like an interesting demographic change which affects growth, and then there's a question of migration and remittances, and then also how all of this relates to climate change in the future.
Yes, the idea behind the land use change because it's not only deforestation, but as you mentioned, perhaps a change in urbanization, for example, no? And that's might be important in terms of emerging infection diseases like COVID. So maybe in the future, these topics about biodiversity protection are going to be central because people are starting to understand that this kind of epidemics might be more persistent or more frequent because land use change and the consequent biodiversity loss and contact with the species that we haven't had contact before and so on.
Yeah, that's a very crucial issue, and perhaps we can learn a lot from it. Let me just give one example that in the agriculture areas of California, almost unique among the US, in the Central Valley, there is a maximum lot size for houses, so that a very wealthy person can't suddenly take 50, 100, 300 hectares out of agricultural production and turn it into a mega estate. And so that certainly is one thing to look at, and the other is sort of intelligent urbanization. I mean, so I agree. Those are very critical, and I think the other question in land use change to me, but I'm far from an expert. This is just an observer. Is, for example, the Chinese purchase of farms in Brazil, which I can see, because if you're concerned about potential food supply in the future, you might want to say, look, I want to have some say over where the output goes. Then it's not clear that their use of it would be in the best interest of people in Brazil. And I think, you know, you can see an example of some of this behavior in the current world scramble for who gets the first billion doses of COVID vaccine.
So I think we're just going over time, and it's a great conversation to try to pick up again towards the end. But let's thank Harold and Tai. Thank you so much for your presentation, and we'll switch gears now to Oliver, who's going to continue with his talk on what does theoretical physics tell us about Mexico's December era crisis. So Oliver, if you'd like to share your screen.
Okay, do you see my screen?
Yep.
Okay, perfect. So thank you for the nicest presentation. It's very interesting, and hopefully we can talk later about future collaborations. I'm very glad to be here in this wonderful conference, and in this work we try to understand better a perfect economic storm that emerged in Mexico and was called, we think mistakenly, under our analysis, of course, the December era, TDE, in 1994, in which Mexico's economy essentially collapsed. And afterwards, this crisis propagates to the world as the tequila effect. So in some background, in the second half of the 80s, after some very important efforts, Mexico was becoming an example of success, stabilization, economic reform, institutional strength, and financial predictability. As I was a kid, I remember this kind of hope feeling and excitement because the enter of stores like Walmart and so on that we haven't had before in Mexico, so it was a big deal for people. Mexico was in fact becoming what Chile already had become, and somehow it was also what Latin America as a region hoped to be, until, of course, the December era. So we think that the December era is a black swan event, but not of this type, of course, but of the type that Taleb described in his work, that actually he presented in the plenary session of Monday, in this book, Statistical Consequence of Fat Tails, that, by the way, people says that smell like olive. And in case someone doesn't know what a black swan is, it's an event that is characterized by rareness of a very low frequency event, extreme impact, and retrospective predictability. That means that we can, afterwards, we can explain what happened and why it happened, and somehow build a whole narrative around the event. But before the event, we have no idea. No? So the black swan concept is maybe an archetypical event of the phenomenological domain of extreme events described by fatal distributions, in contrast of those dominated by characteristic scales, for example, media or means or any other central measurement of the distribution. And of course, they are described by the Gaussian. So we have the central problem of the black swan is not only that we know that this kind of event exists, but also to understand how the system responds to them or any other perturbations. So Taleb has developed this idea about response to perturbation in terms of fragility, anti-fragility. The best example of fragility, of course, is a glass, a crystal glass that if you put on the table and your kids come around with a basketball ball representing aleatoriety, randomness, stressors, perturbation, or time, eventually they are going to break the glass. Something that is that responds in a concave way like this to perturbations is what we call a fragile system, a system that is essentially insensible to the perturbations, to stressors, to time, are called robust or maybe resilient. And some systems present this kind of convex response to perturbation to time, in which they gain from randomness. So this kind of a system are called anti-fragile. So the idea is that even if you don't know when, how a black swan event is going to happen, you may build and develop strategies and infrastructure that enhance anti-fragility for you. So let me tell you why we end up studying this kind of economic crisis, because my background is not an economist, is from theoretical physics, and essentially we have been working around the idea of ecosystem health. So we started with this paper in +1 where we try to bring the idea of how dynamics and stability is important to achieve sustainability, using data from North America forest ecosystem restoration. And then we started to understand that it was not only the dynamics that is important to the system, but also how they respond to perturbations. So we developed this idea, or we how to say it, we applied the idea of antifragility to ecosystem antifragility, and showed that it was a better concept and a better goal rather than just resilience. And finally, because these two works, we started to thinking about how this dynamic represented by criticality, this concept about how system achieves some kind of good balance between self-organization and emergence in terms of, for example, randomness and order, or predictability and unpredictability, and so on. How does this criticality concept relate to antifragility? And then we kind of understand that feature information is a key concept that unify both criticality and antifragility. And then we finally understand that a system, and in this case ecosystem, but we think that this is universal for any kind of system. A system is in a healthy state if they are close to some optimal parameters that allow it to work well, and it has this kind of critical dynamics that enhance sufficient order and sufficient adaptability. And finally, if they can respond in a convex way to perturbations. So that's how we end with this interest in stability and how systems respond to perturbations. And one very nice perturbation is economic crisis. So we started to understand this idea, these ideas developed by Frieden and Cabezas, that proposed feature information is beyond the traditional interpretation about fishery information as a way to know how much inference we can make about, from a set of measurements, we can rewrite fishery information in terms of the first and the second derivative of the perturbations, that we may understand it like velocity and, bueno, tangential velocity and acceleration in the phase space. So a system that has a very high fishery information moves slowly and with low acceleration in the phase space. So the hypervolume of phase space is very small, and then you can make good inference because you don't have to explore the whole space. In contrast to a system that has low fishery information values that translate into very fast movement in the phase space and high acceleration. So they make this very big hypervolume in the phase space, and then you can't make a lot of inference because you have to explore a big volume. So fishery information is pretty much a good measurement of stability of a system. So we use data from Central Bank in Mexico. We try to find data that was interesting for economic understanding of the crisis. So we work with this with monthly inflation from 1969 to 2018, and that is the black line, and then we calculate the fishery information of it, that is present in this blue color, and then we calculate the fishery information of the fishery information, what we call the second fishery information, that is in this light blue. So we can talk about an economic indicator, its stability, and the stability of that stability. So in this graph, we see some very interesting features. In this region from 69 to essentially 1981, we have some sort of low inflation values, medium fishery information with some lower peaks, and high values of the second order fishery information with some higher peaks. So this is a regime of low stable inflation, but with an unstable stability because of this high second order fishery information values. Then we have another regime from 1981, from here to 1987, around here, where we have this economic crisis in Mexico, represented in a big increase of inflation. We have lower values of the peaks in comparison to this region for the fishery information. And again, we have very, very high second order fishery information values that we think might be interpreted like high unstable inflation, and that instability is very stable itself. So then we reach this region that is the Carlos Salinas administration time, in which there are very high inflation values with, in which we see this economic recuperation, the Mexican miracle, but we see that we have this increase in fishery information, but in contrast, we have this decrease in second order fishery information. So if we look exactly some months before the December error, we see these very high peaks of first fishery information and the lowest value of the second fishery information. We think that this combination of very unstable stability might be an early warning for this inflation peak that represents the December error. Then we have this recuperation time. And the idea is that, basically fishery information is letting us know when, for example, the system in here might be achieving these low inflation values using some artificial economic maneuvers for stabilizations that in fact we know the Salinas administration used for making Mexico look good in terms of macroeconomics and make it appealing for investment. So we have this artificial stability, extracting randomness from the system, but that stability is unstable. So we think that this is a very good example of what Taleb called fragilization. When you subtract natural randomness from the system and you make it fragile for perturbations. Another example of this might be the wildfires in Australia. The Aborigines in Australia know that their territory needs some randomness in terms of fires, so they even promote some small fires that consume fuel and avoid the accumulation of it, protecting the ecosystem from these very, very large wildfires. But in recent administrations in Australia, they implement this policy about protecting artificially the ecosystems from wildfires, and they stop promoting these small fires. And then by subtracting the small fires, they promote the big events like we have seen last years. Some remarks and conclusion of what we have seen from this analysis is that physics, of course, is all about nature's laws, but in a deep understanding of how it works, it ultimately recognizes statistical valid patterns. This is the main idea of physics, recognizing valid patterns from data. In that sense, physics might be applied to many other disciplines like economics. We hope that this case of study, in fact, promotes the use of this analysis in physics course and to promote interdisciplinarity. We think that fishery information is a central concept to complex systems. In fact, there is this huge work by Frieden where he used fishery information to understand the emergence of all physical laws. That is pretty amazing. But we, as we are proposing, if fishery information does bring together criticality and anti-fragility, then fishery information might be the central concept that we might be looking for constructing a complex systems general theory. That's a very interesting thing. And finally, for December error, then we think that we have some evidence that point to the fact that the crisis was not due to the change of government from Salinas administration to Cedillo administration that historically he was pointed out that the responsible person for this big crisis, but on the contrary, this was the accumulation of randomness suppression and fragilization on the system because these economical maneuvers implemented in Salinas' administration. And pretty much that's it. In the chat, I will put the link for the presentation if you want to go back to it. And thank you for listening.
Much, Oliver. I think we have time for like one question, and then so Rodolfo asks, since all over the world central banks are pumping extreme liquidity to the world economy, are we in a similar situation of anti-fragility?
I think so. This is kind of a general idea from a lot of administration in the world that we need to control the economy. We need to prevent crisis. Pretty much in the same sense that Australian government tried to avoid wildfires by artificial controls. They are in fact promoting fragilization and constructing the scenario for another big crisis. So until we understand that economy must not be controlled in this artificial way, we are going to see this kind of crisis. That in our study of fishery information, you can see two kinds of different types of crisis. The first one I show you have this was developed in a long period in the 80s, maybe because the coupling of Mexico economy to oil industry, particularly with Pemex, in a time when oil prices was in crisis. So in that sense, that crisis on the 80s was due to external factors. And then we have this other type of very quick and spontaneous crisis, the December error, that are due to this fragilization. So not every crisis are black swan. Not every crisis are due to fragilization, but we have some of those that present recursively in time for many economics.
Thank you again, Oliver. We need to move on to the other talk. There's a couple of questions for you too, so perhaps you can respond there.
Sure thing.
Thank you. So next up is Ansel Renner on his talk on cyborgization of modern social economic systems. So Ansel, if you'd like to share your screen.
Okay. Hi, can you hear me? Let's see if I can.
Yep, we can hear you.
And now you can see my presentation as well?
Yep.
Perfect. Let me start my time. Okay, so hi, my name is Ansel. I'm from the Autonomous University of Barcelona. Today I'm presenting on cyborgization of modern social economic systems. And I'm also going to be giving a few practical notes on accounting for changes in metabolic identity towards the end. Something a little bit different maybe with this presentation and the previous ones in the session so far is I'm not going to be presenting empirical data, but I'll give some notes to that end on related studies that we've done that did include empirical data at the end of the presentation. One last note, Mario Giampietro is also in the audience today in the session, and he gave a related presentation on Tuesday, and there are two conference papers related to both his presentation and his presentation that are related if you want to find out more information. Okay, so I want to get started today with something a little bit abstract, and then I'm going to hone in on something more practical towards by the end of the presentation. And I want to continue now building off, for those of you who were in Nassim Taleb's plenary on Monday. He made a comment about the fact that he was having a debate with another researcher about the point of science, and another researcher was saying that the point of science is to forecast, and Nassim was rejecting that and saying that no, it's about understanding. And I certainly agree with Nassim in that sense, and I would go further and say it's about understanding and also explaining. And in order to explain, we need to be working with a causal framework, whether implicitly or explicitly. And so I'm going to start my presentation today by making that explicit. And bear with me for a moment just to explain it. I'm going to be building a house. So let's build a house together. So a house has what's referred to as a material cause. These are things such as lumber, nails, paint, concrete. Secondly, it has something known as a formal cause. These are things such as the shape and the form of the house, blueprints, design, architectural layout, and so forth. Thirdly, it has an efficient cause, which is the agent of change that acted upon those material and the formal cause to create the house, bring it into being. These are things such as carpenters, painters, operators, overseers, etc. And lastly, it has a final cause. This is the purpose of the house. And there are different contestable final causes. So you might identify the purpose of a house being protection, a status symbol, rental income, a place to lay low, etc. And so together, these are the four causes of Aristotle, if maybe some of you have heard of them before. So the framework of Aristotelian causality. The top two causes are intrinsic to the house itself. They're related to being, they're static, and the bottom two causes are extrinsic. They're related to becoming and something that a dynamic sense. So now ramping up our game a little bit, again, reminding that this presentation is about a social economic system. I want to now take that causal framework and build an agricultural sector. So an agricultural sector is a little bit more complicated than house, of course. We have human activity, which is a vector of control. We have different material inputs, such as electricity, fuel, vegetable, animal products, and so forth. And we have other material aspects that are related to it, such as power capacity, buildings, and infrastructure. And then we also have a set of outputs, expected outputs to society, such as biomass for the energy sector, food inputs for the household sector, etc. And now bringing this back to the causal framework that I started this presentation with, these different material inputs are related to material cause. The general layout of all of these things together in the agricultural sector would be a formal cause. Human activity is my vector proxy for the efficient cause, acting upon these things to create the sector. And the different outputs, purposeful outputs, the different sectors of the economy are examples of different final causes. So now, on the right side, this is what society wants. On the left side, what society offers for it. And now I want to ramp things up again and build a social economic system. So we built a house, we've introduced a causal framework, we've introduced a general concept of how we might conceive of in a causal sense an agricultural sector, and now I want to bring it together and make a social economic system. So the diagram I'm presenting here, I've conceptualized a social economic system as 5 different sectors. Service and government and household on the dissipative side, so they're consuming more than they are producing. And on the hypercyclic side of society, I'm dividing the social economic system into manufacturing, construction, energy and mining, agricultural sector, etc. And these different arrows that I'm drawing, this is a rather conventional look at what a social economic system is. And the different arrows are material inputs and outputs. And you can see that it's well connected. So you have all the outputs from the energy and mining sector, of course, really go towards feeding the energy needs and of all the other sectors and so forth for the agricultural sector. And so in order to complete the explanation here of this diagram, I need to add one piece of vocabulary to our lexicon in terms of the causal framework. So basically what's happening here is the final cause of the different sectors, for example, the agricultural products that are output from the agriculture sector are being transformed into inputs, material inputs into other sectors, and I can refer to this as sequential composition. So the final cause of one process becoming the material cause of a second process. Okay, so that's one side. That's one look at one view into the causal understanding of a social economic system. A companion view of that is this diagram. So here I'm showing again the 5 different sectors that I showed in the previous slide, and I've just reduced some material aspects. And instead I'm highlighting human activity as again the vector of control of efficient cause. And you'll see I've also introduced these hollow-headed arrows. And so now I'm going to introduce one last piece of vocabulary to our causal framework. So if you remember in the previous slide, I talked about sequential composition, the final cause of one process becoming the material cause of a second one. And now here I want to introduce a different concept of causal entailment, where the final cause of one sector becomes the efficient cause of a second sector. And I'm going to refer to this as hierarchical composition. So for example, the household sector is recreating the actors or the agents of change of all the different sectors, and likewise for service and government, agriculture, and energy, and etc. So if you'll notice, most of the nodes in this graph are well connected, with a notable exclusion of connections between the hypercyclic sectors and connections going from the hypercyclic sectors towards the dissipative sectors. And that was a purposeful decision, and something that I would like to comment on. So this causal framework that I'm working with here is inspired from the field of relational biology. I don't know if any of you are familiar with the work of Nikolai Reshevsky or Robert Rosen. And so in relational biology, there's this idea of an impredicative loop, and in that field, it's understood as the wellspring of complexity, the definition of what it is to be a complex system. And so that's basically where the final cause of one process becomes the efficient cause of a second process, works on material cause, produces a final cause, which becomes the efficient cause of a second process, of a third process, etc. And you have a loop that keeps going around and around in a paradoxical sense. So you can think of this as sort of a chicken-egg paradox. Did the chicken come before the egg come before the chicken, etc. And there's no one answer. It depends on how you break that loop. And so if we do break that loop by redefining the boundaries of the system, for example, through externalization or having that system become reliant on inputs or outputs, the system of identity control is broken. And I would claim, at least under this causal framework, that that system is no longer to be considered complex, whereas it may be complicated. And so coming back here and bringing our attention back to the fact that I didn't show these causal connections of hierarchical composition between the hypercyclic sectors and between the hypercyclic sectors going towards the dissipative sectors. And I'd like to comment on what's happening here. So I would claim that that is a process of cyborgization. So that's where the term is coming from in the title. I would also claim that that's being effectuated through processes of urbanization, externalization, globalization. And I would also say that bringing it into the context of Oliver's speech, the previous presentation, that is also a process of fragilization. So this is related to a bit of a provocative term, I'm aware. I don't know if any of you heard of it, the phrase delirium of the urban elite. So the urban pull, and then this is basically speaking to the fact that, or the concept that urban elite are becoming detached from biophysical reality and promoting this conceptualization that so-called wealth comes from an automatic telling machine, food comes from the supermarket, energy comes from the gas pump, etc. And the resulting question of this breaking of the impredicative loop and this breaking of control of metabolic identity is the question of how to control societal identity, assuming that is something desirable. And so now I'm going to switch gears a little bit and talk about a few practical implications working with that framework. And these are going to be practical implications explained textually. And I remind you again that if anyone is interested in this further, there are a lot of empirical applications that we have produced related to this work. So we work with 3 lenses, a macroscope, a mesoscope, and a microscope. And starting us off with the macroscope, basically how we work when we analyze a social economic system, we can talk about looking at the profile of different end uses. So this can be related to, for example, the allocation of liquid fuels or vegetal or animal products towards the various sectors. For example, the 5-sector diagram that I presented earlier. or we can talk about exo and endosomatic metabolic rates. We can also talk about the relation between those two things. So we can talk about a bioeconomic pressure, the differences between the sizes and relative exo and endosomatic metabolic rates of the different sectors, which has a high, by the way, has a, bringing us back to Harold's presentation, bioeconomic pressure is a biophysical look at well, it's a biophysical analog, perhaps, of gross domestic product. It has a very high correlation to that. At the mesoscopic level, we can talk about, in general terms, supply systems. And so when I'm referring to here, we can bring what we've defined at the macroscope, for example, as liquid fuels. We can bring that to a higher resolution. We can talk about, for example, gasoline, diesel, and kerosene. We can talk about bringing vegetable food as a gross nutrient carrier at the macroscopic level, breaking that into grains, vegetables, fruits, etc. We can also talk about those supply systems and the degree of freedom from internal constraints that results from them, both in the technosphere and in the biosphere. And that's related to the level of openness, again, talking about the processes of externalization and globalization that I was talking about previously. Finally, at the macroscopic level, we can talk about, in general terms, production processes. And what I'm referring to, well, so firstly, we can take, for example, baseload electricity, something that could be defined at the mesoscopic level. And we can talk about different production processes that could conceivably fulfill that. And so moving away here from a concept of being able to optimize the production processes to fulfill baseload electricity, but acknowledging the fact that there are different production processes that could possibly fulfill that. For example, nuclear power plants using uranium, coal power plants using anthracite, etc. We can formalize these into a quantitative tool referred to as a metabolic processor. And we can talk about, for example, the technical viability of those processors, how they might be related to different processes of innovation in the society. And finally, we can talk about, for example, if we have different inputs and outputs into those metabolic processors, they have a profile of flows associated with them. We can map those flows, those pressure variables onto, for example, the environment and translate those after local contextualization into impacts. So I realize, I apologize that my presentation was kind of a whirlwind look at this. It was more of a teaser in that sense. This work is related to a large EU project called the Magic Nexus Project. Stands for Moving Towards Adaptive Governance and Complexity, Informing Nexus Security. And so we've produced a lot of empirical studies and publications related to this framework, where you can, if you're interested, see a little bit more of a practical application rather than just this overview. And I also give links or references to the two papers associated with this presentation. The first one directly from this presentation, the second one given by Mario, who again is in the session right now and open for your questions as well, who gave his presentation on Tuesday. And yeah, so thank you very much for your attention.
Thanks so much. Questions for him?
If I may.
Please.
Yeah, Ansel, that was fascinating and very interesting. And I have some other thoughts of how it would fit in with what is an opposite, but I think a complementary view of the whole thing. So like Lynn Ostrom's picture of the organization, the self-organization of socioeconomic systems, the sharing and the sort of resolution of the paradox of the common, as well as other people who've looked in the area. And I'm just wondering how your sort of organizational description and complex system description fits with what I will characterize as, unfortunately, as someone not really in the field, as a sort of more traditional socioeconomic description.
Yeah. Okay. Yeah. Thank you, Harold, for the question. So So I'm aware of Eleanor Ostrom's work on I think you're referring to her work on collective action, and I think that's certainly relevant towards how to handle or how to engage with the system once you have classified it. Maybe I'd like to link with, so I think probably many people in the audience are familiar with the idea of autopoiesis or autopoietic system. This is coming from Maturana and Varela, and basically this is a system that internally recreates all of its, basically all of its processors. So for example, the heart recreates, you know, the liver is related to the kidney, for example, you know, your one encapsulation. And so, and Nicholas Luhmann also, the sociologist, related that idea of autopoiesis of a biological organism to a social system. And so that's a little bit of the same topic that I'm talking to here. One difference, so there's a couple of differences that I might speak to. One, the framework that I presented, both using the Aristotle causality and also the underlying something I didn't talk about, the meta-mathematical language of category theory, which is how this is formalized in the field of relational biology, where that formal framework is coming from. One that offers you some formal tools that were not previously, or that aren't available in the autopoiesis literature, that are different than that. And also it provides a slightly different view. So in the autopoietic standpoint, a living organism is conceptualized as purely mechanical, and then it's related, though, once it's a living system that recreates all of its internal processes, it's related to an idea of cognition. And then that cognition is where your functionality comes into play, where what I talk about as final cause. And so they kind of split those two things. They split an intrinsic causal view of the living organism or the social system or what have you, and an extrinsic view. And I'm kind of putting those two things together, so to say.
So we have another question from Oliver on great talk. I think it gets us closer to socio-ecosystem fragility. Are you thinking of working in that direction?
In some sense, yes. I mean, and a lot of my views on that are simply my, you know, my opinions, and they would need to be, you know, developed into something, you know, a scientific framework, so to say. But so yeah, I mean, when you, Oliver, in your presentation, when you were talking about fragilization, this is that struck home as something that's very similar to my critique of what I claim to be happening with social economic systems in terms of moving towards a cyborg model. So basically, the difference between a living system and a cyborg system is a living system is completely, in technical terms, closed to efficient causation. So it's completely reproduces all of its efficient causes, all of its processors that are used to recreate it. So for example, a human body, you know, all the organs recreate themselves. And of course we consume material inputs and get rid of waste, but we know we're our own encapsulation, whereas a cyborg system is that system plus an artificial component that is no longer reproduced by the system. So for example, that's a pacemaker. Somebody with a pacemaker, from the concept, again, this is, you know, just the concept from relational biology, is a cyborg in the sense that they don't recreate the pacemaker, they're reliant on that artificial component. And I would say that is a process of fragilization. So I think that is a very promising direction.
Yes, that is a very interesting interpretation. In fact, we have working on this idea about ecobionts in terms of an expansion of the idea of allobionts, but including this technological coupling. So yes, I think your work is very interesting and fascinating, in fact, and it might be a good way to start understanding these highly coupling systems. Thank you. Great talk.
Thanks for the comments. Also, I think Mario has his hand raised. He also worked on this presentation. I don't know if he wants to say something.
Yes. Hi, everybody. I wanted just to say that probably this doesn't come out from the presentation, that the three levels make possible to describe the level of self-entitlement of the different elements using different metrics. So basically, what they were at the beginning, they are vectors with actual numbers. So you can really define the metabolism of these things using one set of numbers with metric 1 when you are on the macroscope, microscope, and mesoscope. And then you can relate these to social practice, what humans feel in their daily life, because you are mapping the energy per hour on each of different categories of human activity. They are included in the system. So I mean, I'm not sure it was so evident, but all these things can be, as a matter of fact, what we do in the project, described in quantitative terms. We are using data from statistics. No, it is not just an idea what could be done. We've been doing this for 4 years, and we have data for all Europe for a pretty good quantitative representation. Thanks, sorry.
Thank you, Marian and Ansel, for the presentation. I think we're going to move on to our last talk by Oliver. And certainly, if you're following the chat here, we would really love to continue these discussions on our Slack channel, and there's some instructions on how to set that up. But let's go back to Oliver. Oliver, do you like to share your screen? And our final talk is on the devil is in the interactions, SDGs that works to enhance coherent policy.
Thank you. Let me share the screen. This one. Okay. Thank you again for staying with us. I think the last talk is fascinating. A lot of ideas and practical new field for work. In this talk, I was yesterday. I started to see this Netflix series about the mafia and New York City. It was very interesting because even in the first episode, they talk about the RICO law and how it turned to be the key ingredient to fight against the mafia, because before that, police could only arrest individuals, the soldiers of the mafia, but never really got into the captains and bosses, because they isolate themselves from the crime and took only the money from the soldiers. So the RICO law was thought as a way to rethink the fundamental unit of analysis, moving from the individual to the network. So the RICO law allow police to arrest not only the individual that commit the crime, but all the network around the crime. So it is very interesting because there is a very clear difference in thinking about interactions or ignoring interactions. So in this work, we go in this direction on the SDGs goals. But let me give you somehow a background why we end up here. We used to give a complexity ecology course in the complexity science center at UNAM, and we end with this idea about how to teach complexity, and we think that the best way to teach complexity is facing complex problems. So we present problems to our students, and they develop this problem into the semester. And usually we try to end with a paper. And in this first try, we identify some competence necessary for teaching complexity. I'm not going to present all the competence, only two examples. This is the first one, the systemic competence, where we think that the student must be able to understand the fundamental causes of complex systems, for example, identifying the various interaction between causes and effects. In the same way, he or she is expected to know how to recognize the actions and motives behind them by considering different actors. In the same way, the student must be able to understand dynamics, distance and cascade effects, as well as reaction and inertia that appears in the approach to the problem. So this is basically a competence to understand ecosystems and so on. We think that is also important for understanding complex systems, having a precautory thinking competence, because due to the fact that complexity expresses itself in the real world, usually in wicked problems. Therefore, we need to assess when it is absolutely necessary to implement an interventions rather than allowing the system to self-organize. This is important because as complex system, as pointed out in the last presentation, is unpredictable and pretty much uncontrollable. Every time that we try to implement global interventions and big solutions for big problems, we end up with another big problem we didn't see before. So it's important to understand that and to apply the precautionary principle that talks about when risk escalates to and propagates to the whole system, and when the risk stay in a local scale. So it's very different, the risk from a nuclear plant from the risk from genetically modified organisms, because in the first, the risk stay local, even if it's horrible and great consequence and so on. If a nuclear plant blow up, it doesn't propagate to other nuclear plants and make those plants to blow up either also. But in the case of genetically modified organisms, this kind of interventions, because they are implemented in open systems that are highly coupled, we can't restrict it in a local environment, but will propagate to the whole system. So these are two very different kind of risks. And finally, the last example of this competence is skin in the game. And we think that when you make an analysis or propose a solution, or if you are decision making, you cannot and you should not be isolated for the consequence of your analysis or your decisions. So this is the idea behind the work I presented before, that if you are in a presidential chair like Carlos Salinas, and you think that it's a very good idea to artificially control the economy, and then you blow up the economy, but you remain isolated, you can go and enjoy your life and nothing happens for you. So as long as that prevails, we will still see this kind of crisis because fragilistic interventions. So going back to the main topic of the talk, this is the SDGs that proposed in 2015, in which basically all countries in the world signed this 2030 Agenda for Sustainable Development, trying to fight inequality, injustice, climate change, and basically all the important problems that we are facing as a global society today. One big problem is that there is no well-documented, consistent, and methodological robust enough data for understanding or for measurement SDGs. So we have to focus in a more restricted subsystem that is major cities in Mexico. This is a very nice work done by Citibanamex in Mexico, where they developed this Sustainable Cities Index, using information from basically all possible government agencies and and on NGOs, and they developed the index for covering the most important metropolitan areas in the countries, 59 of them. So we use this data and calculate the mutual information, not a correlation, because correlation has some problems in terms of non-linearities, and we think that entropy-based measurements are better. So we calculate the mutual information, and with this mutual information, we constructed the interaction network for SDGs. And then we compare this empirical network against a theoretical one developed by Nielsen and co-workers, where they apply this kind of subjective scales in terms of if one SDG is indivisible with another one, then you put it a +3 value in the network. If, for example, an SDG cancel another SDG, then you put a -3 value in the interaction, and so on. Then we use Cytojava package in Cytoscape to calculate several informational network measurements to try to ranking the SDGs. As you may know, these network measurements are some kind sensitive to computational calculations. So we made 1,000 iterations to have a better measurement of it. And this is the result. We have, for example, that in the empirical network, the SDG number 1, poverty, comes out most of the time in third place or second place, comparing to how it is ranking for the theoretical network, in which it ranks most often in the 4th or 5th place, and so on with all the SDGs. So we kind of generate these two different narratives from theoretical and empirical. In the theoretical network, the subjective analysis focus more on health, hunger, poverty, and in the empirical network, the data is structured more in terms of work, industry, hunger, and poverty. So in general terms, a theoretical network corresponds to a mental model from the experts focusing on people, on the so-called people SDGs, the 1, 2, 3, 4, 5, and 10, being the most important: good health and well-being and zero hunger. That's the mental model they seems to be using. And on the other hand, the empirical network for Mexico metropolitan area is focused more on prosperity SDGs, the 7, 8, 9, 10, and 11. Then we constructed a Bayesian network in Genie software and try to understand what happened if we ignore interactions against recognizing it, and try to perturbate the network to understand which SDGs are more important. So we find that there is a probability of 65% of low progress in the SDGs agenda, 30% of medium progress, and 20% of high progress. But we also see that, for example, SDG 10 and people's SDG are more likely to present low or medium progress if we ignore interactions. So we compare this scenario in which we recognize or ignore interactions, and the result is most interesting because it shows that in general, ignoring interaction makes much more likely to have low progress in the SDGs agenda. Nevertheless, there are 3 SDGs that by themselves would make a good difference, even if we are in this interaction framework and we need to talk about the network and not only to one SDGs. These 3 are very important, even in the network framework. The first one is the SDG 9, responsible consumption and production. The second is SDG 12, peace, justice, and no, I'm sorry, I'm telling you that. The first is SDG 9, industry, innovation, and infrastructure. Then we have responsible consumption and production, SDG 12. And finally, peace, justice, and strong institution, the SDG 16. Finally, we instead of construct the traditional 3 problem, we are proposing this new multi-scale complex 3 problem in which you need to recognize or identify the root cases of the problem as a network that interact informationally with near causes also as a network, and then it manifests itself in the SDGs network as the core problems, and finally you can see a network of consequences. So in the root causes network, we have, for example, a lack of sustainability vision, principal agents problems, inequality agents problems, no social prices in current policies, lack of law enforcement. This is very important because, for example, in this example of the mafia fight, it was the law strong infrastructure in the US that allow the fight against mafia. In the near causes, including among others, we can find, for example, low financial inclusion, too many subsidies and transfer programs, poor quality education, poor quality in health services, and so on. In the core problems, we are thinking about, of course, problems related with SDGs, compliance that manifests itself in consequences susceptible to be captured by indicators. So this is what we have been doing or thinking about the SDGs in a complex system network in terms of the interactions. So we think that the table is in the interactions. And some remarks and conclusions might be that basically what we need to enhance is a more sustainable scenario is an appropriate ecosystem for creating wealth, a responsible consumption culture, and strong institutions. Also, we must remember that our results are only valid for metropolitan areas. So it could be the case that for rural regions, the poverty fight approach is still correct. We don't know that because there is no good data for testing it. Policies should be designed to be dynamic, never static. No analysis designed for a single period should be used dynamically. And this implies a mechanism for policy evaluation and feedback. If you can't measure, you can't adapt. These policies should be also multi-scales, never a single scale. No interpretation should be extended beyond the scale for which it was designed. We should also recognize the natural hierarchy of complex adaptive systems. So one policy that works fine in the federal scales should not be implemented automatically in the municipality scale and vice versa. A precautionary approach should be enforced always at higher scales, recognizing that the principal objective of the state is implementing what risk management and control cannot do at lower levels. And finally, yes, we need evidence-based policy, whatever that means, because nowadays evidence-based is very distortionate concept. But also, we think that we need complexity-based policies. So again, thank you, and that's all.
Thank you, Oliver. Questions?
Let me throw out one if no one else is. I do like the use of mutual information. I mean, that's clearly otherwise we're you know, as exactly as you said, lots of other measures assume a linear world. When I look at, for example, a variety of potential goals, and you have a network around this. Maybe this I didn't understand, but it seems to me that I don't just want to understand correlations or nonlinear ones as mutual information gets. I want to understand some sort of causality. In other words, sort of naively, I don't know, the first X of one's income goes to food and shelter, and the next X goes to some other necessities, and then so on. So there are some hierarchical relationships around this, and you know, priorities. And I'm just wondering, how does one build those into a into this network picture you have?
I think that in order to construct causality, we need time series data, because ultimately you need to see cause and effect, and that implies time. Time entering into play. So the problem here is that we have only one year data. So for us, it is in our scope to construct these causal relationships, but we need time series. Without time series, there's no way to understand causality.
Thanks. Yeah, and I enjoyed the talk. It was just, yeah.
Thank you.
So we are out of time, unfortunately, and as always, there's always more questions than we can accommodate, but please do take advantage of the Slack channel to continue these discussions. I'd like to thank again all of our presenters for the great talks today, as well as for you all for joining. And there's a link to the upcoming session in the chat as well. I look forward to seeing you all at another session. So thank you again, and take care, everyone.
Thanks all.